Chapter 9 is all right triangle stuff. This first stuff, similar right triangles. It's related to what we just did in chapter 8, where you can do proportions. It has to do with if you've got any kind of right triangle, and then what they do is they draw in an altitude here to make two other right triangles. What you get is 3 triangles that are all proportional to each other. So, if I were to label all these, if you redrew this, you'd have the big triangle, ABD. And I'll try and tip these so they all are the same orientation. If I took this triangle, ACD, and reflected it and turned it, it would look like a, oops, that's C, like that, right? And then if I took this one and then reflected that again, it would be a little bit bigger than that one. And C is the 90, B is up here, A is right there. So you can get these 3 triangles out of this picture. Now they're not all to scale, but you get the idea, right? I could turn this one and put it in there, and turn this one and put it in there. So, remember on any right triangle, there's 3 sides, right? There's 2 legs and a hypotenuse. You gotta know how to identify the legs and the hypotenuse. The legs form the 90. And the hypotenuse is opposite the 90. So you absolutely know how to spot the hypotenuse in this whole chapter for everything that we do in every section. The hypotenuse is always the longest side. So looking at this picture right here, turn this, we can write proportional statements. It's kind of hard to figure it out just by looking at this main one. But here I can see that AB and BC, or AB is proportional to BC, right? And AB is also proportional to AC in this one. See, because these are corresponding sides. And then BD corresponds to BA, which corresponds to AD. And AD corresponds to CA, corresponds to CD. So you can write proportions to find missing values in these triangles. So for example, you're going to have something like this. This is 8, this is 6, and they're going to look for that. So you got to write a proportion to solve it. Or they may have, this is X and this is 10, you're looking for that. Okay? This proportional thing here is the absolute hardest way to do it. I'm going to show you how to do it the easier way. Okay? So, you guys remember geometric means?
Not really.
If you got 2 numbers and they want you to find the geometric mean of those 2 numbers, you write a proportion. You just put those 2 kitty corner from each other, and then you put X in the other 2. So then this would be X squared equals 48, because remember the cross products are equal. So then you square root it. Now this is why that worksheet we did, simplifying radicals, because they don't want a decimal on most of these, they want them in radical form. So X is the square root of 48. So to simplify it, what perfect square goes into 48?
3,
4 does,
5, 8.
16 does. 4 would work, but then you'd have to simplify it again. You always want to get the biggest one if you can. 48 is 16 times 3, which would simplify to 4 squared to 3. Okay? So, you need to set up, you need to write proportions with geometric means to solve this. And I'll show you, it's going to take a little bit of memorizing, but it's not that hard to memorize. So, if you've got a right triangle with an altitude, it's the same one I just drew, except I just tipped it so I got room underneath. You have 1, 2, 3, 4, 5 different segments in this picture, right?
Right.
Okay. This piece right here is a geometric mean to these two pieces right here. Okay? So what that means is if you know, if you're looking for that, and say this is 6 and this is 12, this piece is a geometric mean, which means when you set it up, the geometric mean goes in there twice, x and x. And it's the geometric mean to each part of this, 6 and 12. All right? So once you set it up, you just got to solve it's x squared equals 6 times 12 is 72. So when we square root that, square root of 72, 36 times 2 is 72. So you'd simplify it to 6 squared to 2. Now, sometimes they have it like this. And you're looking for this piece. Again, this piece is the geometric mean. So that piece always goes in there twice. So 8 goes in there twice, and again, it doesn't matter where you put them, here or here, it gotta be kitty corner. And then what would the other two be?
12.
X and 12. So this is an easy one, it's just 8 times 8 divided by 12. So 64 divided by 12. Yep, 5.3 repeating. Okay? Or it may be one like this. 8 and 6, and you're looking for that. Same thing. This is the geometric mean. So it goes in there twice. And then it's 6 and x. So this one's 64 divided by 6 is 10.6 repeating. Okay, Sarah, can you put that away?
Sorry, I was using that stuff better.
Okay, so this piece is a geometric mean to these two pieces of the long. You're always going to use these pieces right here. Then the other one is if it's one of the legs. This piece is also a geometric mean. And this one is a geometric mean. Okay, depending on what you're looking for. So, say for example they were looking for this, and they said this was 6 and this was 12. So now, I mean, this, we're not even looking for this. So that's the geometric mean. And then when it's one of the legs, if it's the piece in the middle, you take each part. If it's one of these legs, what you do is you take the part hooked to it and the entire length. Okay? So it'd be x squared equals 6 times 18, then you'd solve it. So if this was 10 and this was X, and this was 12. 10 is the geometric mean. This piece hooked onto it is X,
X 12.
and it's X plus 12, right? Okay? Same way if it was like this, where you knew this, and this was X. 10 goes in there twice. 8, the piece hooked onto it, and then the whole thing, which is X plus 8, or 8 plus X. So again, it's just like the stuff we did. Once you write it, you gotta solve it like we did in the last chapter. This one, you'd have to write an equation. 10 times 10 is 100, equals 8 times both of those, 8x plus 64.
If you take away 54.
Minus 64 divided by 8,
26, and then you get
36.
36, and then you get that, and then it equals.
4.4. 4.5.
That's right.
Okay. Hello. Hey. Okay.
22.
Okay. Yep. So, the same thing, if you're looking for this one, let's just say this is 20, and you're looking for X there. This is a geometric mean, so it goes in there twice. And then, again, you use this part, but you would put the part hooked onto it and the entire part. Okay?
Wait, will there ever be like two geometric means? Like
No, it's always either gonna involve this, this, or this, not all three.
Okay.
Oh, that'd be crazy.
So if this were X and this were 20 and that was 8, X is what we're looking for, so that goes in there twice. Again, it doesn't matter if it's this way or this way. And then it's the piece hooked onto it, 20, and then the entire length, 28. Okay? So what you gotta remember is this is a geometric mean, so that would go in there twice. And the other two numbers you use are each half, or it's not half, but each part. This is a geometric mean, and the two numbers you would use is the part hooked onto it and the entire length. And then this is a geometric mean, so you'd use this part hooked onto it and the entire length. Okay? So, it's just something you're gonna have to try and memorize. So in this picture, this one you kinda gotta go about in a roundabout way. They're looking for the height right here. So, I could call, remember when you're dealing with this, I don't even need these right here. So, the H is a geometric mean. So what can I put in there?
11.
11.7.
Well, this one we really can't solve because one of them would have to be X and the other one would have to be 11.7 minus X. So what I gotta do is this. Before I can solve H, I gotta use one of these two.
Do 11.
I'll do 11. So 11, remember, is a geometric mean. So 11, you use the piece hooked onto it, which is what? X.
11.7.
No. You can just call it X because we don't know it. The piece hooked onto it and the entire length.
Oh.
Right?
Yeah.
So 11 times 11 divided by 11.7. Divided by 8.7. It would round to 10.34. Okay? So, now that I figured that out, I can find this piece, right?
Yeah.
Yeah.
Cause the whole thing is 11.7 and then minus 10.34 is 1.36. Now I can find H.
Well, you put
1.36.
H goes in there twice, cause that's a geometric mean, and then you use each piece, 13.6,
1.36.
or 1.36, yeah. And 10.34. So, if it's one like this, if it's one like this, you don't need, you're not gonna be able to simplify it in radical form. So you would do it in, you can round them in decimals. So h times h is h squared equals 1.36 times 10.34. So what do we do to figure out h? Square root it. So it would be 3.7. So that was one where you had to do, even though it didn't show you, you had to do one step to get to the next step. Now, these are a little easier. To find AD, that's your X. So on these three numbers, or three things on here, which one is the geometric mean? 24. And when it's this middle piece, you gotta put each part in there. X and 18. So, this one you can just solve 24 times 24 divided by 18. And you get 32.
Hey, 24 times 24, is that 248?
No.
I mean, is it 296?
So, here you gotta find NQ. So that's your X. So of the three things here, which one is the geometric mean?
10.
Right.
Well,
So, remember, this, or this. Those are the three things that will be the geometric mean. And you only use one of them. They'll only have a problem with use one. So, when it's the middle, you use each part. When it's one of the outsides, you use the piece hooked onto it and the entire length. So it'd be 10 times 10 divided by 26. And these are long decimals, so usually we round to the nearest tenth. It would be 3.8. Okay? Because remember, when it's the leg, you use the piece hooked onto it, which we don't know, and the entire length. If it was this one, you'd use this piece hooked onto it and the entire length. But if it's the middle, you just use each length. Okay? So we got to spend, well, obviously another day on this tomorrow.